All right, everybody, we're going to get our DAP on with a tripeptide question. Part 2, acid-base reaction from winter 21. Test 2, part 2. It already says part 2. So we're given 5 pKa. And it says this is the one where 2 of them are missing. I know it doesn't say those words. How did I figure that out? There's 2 of the H's are missing, and I can tell you which 2 right now. But what words tell you 2 H's are missing? Well, one of them's not words. One of them's the fact I gave you 5 pKa, right? And I'm telling you only 3 protons are left. 3 protons are left. Not this one and not this one. Those are the 2 that are removed first. How do I know that? They have the lowest pKa. Lower pKa reacts before higher pKa every time. Do not try to live in a universe where that's not true. Okay? So, this molecule is acting as an acid or a base. If it acts as an acid, the pKa is 4.9. If it acts as a base, one of those 2 places that lost an H is going to get the H back. Which one gets the H back first? I'm not even finished reading this question. I do not know if this molecule needs to be a base. But if it did need to be a base, the pKb would be 14 minus 4.2 equals 9.8. If this molecule needs to be a base, you would not make the pKb 12 react before the 9.8 for the same reason you react stronger acids before weaker acids. You react stronger bases before weaker bases. Quiz item, which base is a stronger base? 9.8 or 14 minus 2 equals 12? Lower number means stronger. 9.8 reacts first. Okay. So the carboxylic acid has lost its H because this is triprotonated and not tetraprotonated, and it's the one closest to the amide of DAP. DAP amide is here. This is the base we're talking about. That would only be necessary if this is the acid of this pair. And it's not. So all that blue discussion for pKb, not a waste of time, but also not for this question. You want me to make it part of this question? An equally good question? Switch these 2 molecules. Just switch them. You have a new question. Switch these 2. In that case, the one with 1 more H is the acid. This is an acid on the left side. It will need a base to react with, and it will be this one, and the H will show up here. But in this question, this species with only 1 H is the base, and the one with 2 H's is the acid. Give me a number. You don't memorize it. It's given. And don't tell me it's 9.1. That's the one where there's 3 H's. How do you know there's 3 H's in the 9.1? Well, how many pKa's did I give you? 3. If all of them were there, then you'd say 9.1. If only 2 of them are there, the next best is 12.7, pKb 14 minus 12.7. And that's 1.3. And this is not relevant for this question. I'll consider doing a video where I do exactly what I said, and it's an equally good video. I think we should, where I take this exact question and switch the boron molecules one side to the other. We should do that next. And I'll say, make sure you see the previous video first. This is going to go fast. Okay. All right. So pKa is 4.9 for this acid up here. It's the asp carboxylic acid, which means it's changing and the rest of the molecule's not. And you don't want to draw the whole thing, do you? Okay, I'm going to do this on the test. You're going to do it too. CO2. What happened to CO2 when it lost a proton? The red CO2 lost a proton. What did it become? Not CO2. Minus. If you write R CO2 minus and you haven't circled anything over here, you're going to get 0 out of 2. R's are very useful, but only if you use them properly. You're not allowed to use them improperly. If you're going to say R, you better tell me exactly what R is. R is everything up to but not including the CO2H. That's what the blue said. Okay, there you go. You saved yourself a lot of time, didn't you? That's 2 points for that. I need to see the circle, what you're calling the circle, and then the short form for the circle here. And we're not quite done. We're going to circle the arrow that points to the larger pKa. So 12.7 is larger than 4.9. pKeq is always the left. 4.9 minus the right. Oh, smaller number minus bigger number. If you're like me and no calculator, I got to do the bigger minus the smaller and then change the sign, because the sign is wrong. And that's an 8, and a 1 to 4 is a 7, and it's a negative 7.8, because you got to go negative. (10 to the positive 7.8). That's big time. Right side favored, right? Right side favored. And we did the 2 pKb's. pKb. Didn't do the pKb. What's the pKb here? pKb 14 minus the pKa of its conjugate acid partner. Which of the numbers did you use? Wow. The conjugate acid of this molecule. What number did you use for pKa? 4.9. It's not related to the 12.7 molecule at all. They are not related with the number 14. And 14 minus 4.9 is very similar to, oh, we already worked it out. It was a relevant number. I said 4.2. Wow. Yeah, it wasn't a relative number. That was so close, I thought we were doing this calculation again, and we're not, are we? Because it's a different acid. And that would just be 9.11, is that right? 9.1 plus 4.9 is 14, yeah. Ooh, exhausting. So our next video, we're gonna have the same question, except to be a modified version, and we'll have the boron species switched. These two will be switched, and it's a whole new question, by the way. That's why it's great.